Hi everyone! Today I'm going to teach you lesson 12-3 about geometric sequences. In lesson 12-1, we did start to talk about geometric sequences when we introduced what sequences are. So hopefully you'll remember a couple of things for your warm-up today. So to start our lesson, we're going to do a warm-up. I want you to consider the geometric sequence whose first three terms are given by 2, 8, and 32. So pause this video, take a couple of minutes to go through parts A, B, and C, and then we'll walk through it together. So let's take a look at part A. It wants to know what the fourth term of the sequence is. So for me to figure out the fourth term, I need to figure out what the pattern is between the three numbers that I've already given. The last lesson we talked about arithmetic sequences, that was an adding pattern. So today we're going to be exploring geometric sequences which have a multiplying type of pattern. So to go from our first term to our second term, so going from 2 to 8, I want to think about what could I multiply 2 by to get 8. So I'm thinking in my head 2 times 4 gets me 8. And I want to make sure that that's correct. I'm going to check it as I go from 8 to 32. 8 to 32 is times 4. All right, so we've got the right multiplier. We're going to do it one more time to get our fourth term. 32 times 4, and we're going to get 128. So our fourth term is going to be 128. How many times was 4 multiplied by 2 to get the fourth term? So let's go back to part A. I multiplied by 4 1, 2, and 3 times. So I multiplied by 4 3 times to get the fourth term. How can we apply what we learned in part A and B to find the ninth term? So what we could do is we could continue that pattern to figure out what that ninth term is going to be. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I already have the first 4 terms. I've got 2, 8, 32, 128. And if I continue multiplying by 4, I can get the ninth term. So let's try this out. Times 4, times 4, times 4. And I'm just going to keep on multiplying by 4. I'm just going to write out this pattern just to help me figure out the next term. Okay. All right, so I'm going to go to my calculator. I'm going to do 128 times 4 to get my next term, which is 512. Now I'm going to do 512 times 4, and that's 2,048. Then I'm going to multiply that by 4, which is 8,192. I'm going to multiply that by 4, which is going to get me 32,768. And then I'm going to multiply that by 4, which is going to give me 131,072. Okay, so we could continue that multiplying pattern to get my ninth term, but there is a shortcut method similar to the arithmetic sequences that's going to help me get these terms a lot quicker. So let's think back to our first example here where we multiplied by 4, and we multiplied by 4 3 times, which was 1 less than the term number, right? So I did 4 times 4 times 4. So I multiplied by 4 3 times to get the fourth term. We're going to look at a similar pattern with this last one. So let's think, how many times do I multiply by 4 to get to the ninth term? I multiply by 4 1, 2, 3, 4, 5, 6, 7, 8 times. So we multiplied by 4 8 times. 8 times. When we have repeated multiplication, we have a shortcut writing method to do right that. So times 4, 8 times, is the same as 4 to the 8th power. So let's see if we can figure out how we can write a shortcut method so that I get my final answer of 131,072. So let's see, if I figure out what 4 to the 8th is, will I get the right number? I'm gonna get 6, 5, 5, 3, 6. So I'm not getting the entire thing of 131,072. So I want to think a little bit, how am I going to get this answer using everything I have? So if I think back, I've multiplied my first term. So my first term here, I multiplied by 4 8 times. So don't forget, we are multiplying the 2 by 4 8 times. So I want to do 2 times 4 to the 8th. And let's see if we get the right answer for that. And you get 131,072. So that's our shortcut method. We could have done the same thing for part A if we wanted to. We could have done our first term of 2 times 4 to the 3rd power. Okay, so let's look at the explicit form of this geometric sequence that's going to help me for the rest of the lesson. So the explicit formula for a geometric sequence is represented by a sub n is equal to a sub 1 times r to the n minus 1. Similarly to the arithmetic sequence, this is going to be given on your reference table or your reference sheet, so you do not need to memorize it. You just need to know what each variable represents so you're able to use it appropriately. So if you want to write yourself a little note, this is going to be on your reference sheet. So for any test or the Regents exam, you will have this able to use. So let's start with a sub 1. A sub 1 is our first term in the sequence. R is what our common ratio is, what we are multiplying each term by to get to the next term. So our common ratio, or our multiplier, and n is the number of terms. A sub n is going to be your total value. Okay, so let's look at example number 1. Use the sequence below to complete each task. We've got 2, 6, 18, and 54. So I'm going to first figure out if this is arithmetic or if this is geometric, based on if there is a common difference. Are we adding or subtracting something, or is this a common ratio, or are we multiplying something each time? So 2 times 3 is 6, 6 times 3 is 18, and so on. So this is going to be a geometric sequence because we have a common multiplier or a common ratio each time. If you're having a hard time figuring out your common ratio or how you multiply each term to get to the next, there is a little bit of a shortcut method to help you. So for your common ratio, you can divide your second term by your first term. And you can do that for each continued term. So you could do the third term divided by the second term, the fourth term divided by the third term, and so on, just to check your work. So if we check that out, we're going to have 6 divided by 2 is 3, right? My second term is 6 divided by my first term of 2, and our common ratio is 3. If you want to check to make sure that's right, you could do the third term divided by the second term. So let's try. 18 divided by 6 is 3. So the ratio of the terms is the same each time, so our common ratio is 3. Write an equation to represent the sequence. So I'm going to go back to my explicit formula to help me do that. So I have a sub n is equal to a sub 1 times r to the n minus 1. Okay, I'm going to zoom in a little. I'm going to substitute in the two things that I know. I know what my first term is here is 2, so that's my a sub 1. And I know my r value is 3. So I'm going to substitute in here. A sub n is equal to my first term of 2 times 3 to the n minus 1. And this is my explicit formula. If I want to figure out any term in the sequence, all I have to do is substitute in n for the number of terms, and I'll be able to figure out the value of that term. So why is it useful to have an equation for this sequence? It's useful because it's a quicker way for me to figure out any term in the sequence instead of having to complete the pattern every single time to get to the term. So again, it is useful because it helps us find any term in the sequence in a quicker way. Okay, so using our quick shortcut method, we're going to do part D to help find the 7th term in the sequence, or a sub 7. So let's do a sub 7 is equal to 2 times 3 to the 7 minus 1. You could simplify your exponential value of the 7 minus 1 to get 6, or you could put the entire thing in the calculator exactly as you see it. So when you're putting this in your calculator, make sure you have the parentheses around the 3 and that you're raising both the 7 and the minus 1 to the exponent. So let's go ahead and put that in your calculator. And it's 2 times 3. I'm going to use the caret key. So our caret key looks like this to help raise it to an exponent. So I'm going to raise it to the power of 7 minus 1. And we're going to get a sub 7 is equal to 1,458. So a really nice, quick way to get any term. That's going to be really helpful later on when you're trying to find like the 20th term, anything big. It's a nice shortcut. Okay, let's move on to example 2. Which of the following choices is the formula for the nth term of the sequence 54, 18, 6, ... All right, so first let's think about our common ratio. So our common ratio is how do we multiply to get to the next one. So I'm going to use that shortcut method I figured out before. I'm going to do my second term divided by my first term. And I'm going to get r is equal to, if I put it in my calculator, I get 0.3 repeating, which is actually equivalent to 1/3. So my common ratio as I go from 54 to 18 is 1/3. And let me just test it out to make sure I'm right. So I'm going to do the third term of 6 divided by the second term of 18. And we get 1/3. So our common ratio each time is 1/3. And I'm also going to identify my first term, which is 54, which is a sub 1. So I'm going to write down the explicit formula. A sub n equals a sub 1 r to the n minus 1. I'm going to substitute in what I know and then compare it to the answers at the end. So I'm going to put this in. A sub n is equal to the first term of 54 times my common ratio of 1/3 to the n minus 1. So let's see if that's a choice. So I can automatically tell that choice 1 and 3 are going to be incorrect because they have a sub 1 listed as 6, and we could tell right away that 6 is not the first term in this sequence. So we're down to choice 2 and 4, and I can see that choice 2 is missing the n minus 1 part, so it just has n. So my final answer is going to be choice 4. We have a starting value of 54 I've got a common ratio of 1/3, and then my exponent is to the n minus 1. Because we're multiplying each term by 1/3, one less time than the term. All right, let's try example 3. Write an explicit formula for the nth term of the following sequence: 5, -10, 20, -40, 80. Whenever it asks you to find the nth term, you're just going to be writing the explicit formula. That means leave n in the answer. Leave n in equation. Okay, so the first thing I'm going to do, I'm going to write the explicit formula just to remind myself of the pieces that I need. So we have a sub n equals a sub 1 r to the n minus 1. So the two components I'm looking for is my first term, and I'm looking for my common ratio. So I want to make sure I have these two things before I go into my equation. So my first term, my a sub 1 is 5. And to get r of my common ratio, I'm going to use my little shortcut method. And I'm going to do my second term divided by my first term. -10 divided by 5 is -2. All right, so I have both components that I need for my equation. So I'm going to get started by plugging in. Okay, so a sub n is equal to my first term of 5 times my common ratio of -2 to the n minus 1. So that is the explicit formula for that given sequence. Now to figure out what the 20th term is, all I need to do is substitute in 20 for n. So a sub 20 is equal to 5 times -2 to the 20 minus 1. And we can put that right into our calculator to figure out what the value of that term is going to be. So when I plug that in, I'm going to get a really, really, really big number. And you're going to really understand why this equation or this formula is so great, because it would have taken us a really long time and we would have been dealing with a lot of big, crazy numbers. So when I put this in my calculator, I get a sub 20 is equal to -2,621,440. So that is the final answer for a sub 20. Our last example is going to seem kind of familiar to you. It kind of goes hand in hand with our previous unit on exponential functions, and it kind of ties in with our geometric sequence where we're talking about kind of like an exponential pattern because we're continuously multiplying by the same number. So let's see how that ties in with what we're doing now. Example 4. A car depreciates by 20% each year after it is purchased. The table below shows the value of the car over the first 3 years. We're going to do the same thing we did for all of the other examples by finding the first term in the sequence and also by finding the common ratio. So the first term in the sequence is 1200, so that's my a sub 1. And I'm going to also try and find my common ratio. So on the side, I'm going to divide my second term, 9600, divided by the first term of 12,000. And I get my common ratio of 0.8. So I'm going to write an equation to represent the sequence by using the explicit formula. So I have a sub n equals a sub 1 times r to the n minus 1. I'm going to substitute in those two values. So a sub n is equal to my first term of 12,000 rather, times the common ratio of 0.8 to the n minus 1. Now to find the value of the car after 8 years, I'm going to substitute in 8 for n. So a sub 8 is equal to 12,000 times 0.8 to the 8 minus 1. And the value of a sub 8 is 2,516 and 58 cents. Okay, so now I'm going to ask you to try some practice questions on your own. For the first 5 questions, it's similar to the practice that we had last week. You're going to be given a sequence. You need to find the common ratio, the first term, the nth term, which means you're substituting into the explicit formula, and then I'm going to ask you to find the 8th term. So I'm going to walk you through example number 1. Given the sequence 5, 10, 20, we want to find that common ratio. So we can either figure it out by looking. So right away I can tell we're multiplying by 2. But if you were unsure, don't forget you can use your shortcut of dividing your second term by your first term. And we get 2. So our common ratio is 2. Our first term is 5. Our nth term, we're going to substitute in those values I have. So a sub n is equal to our first term of 5 times the common ratio of 2 to the n minus 1. And to get my 8th term, I'm going to substitute in n equals 8. So a sub 8 is equal to 5 times 2 to the 8 minus 1. So a sub 8 is equal to 640. Okay, so you're going to repeat that for examples 2 through 5, and then to finish up there is a word problem, word scenario at the end for question number 6. So this is what you are going to submit to us today. We'd like you to submit a copy of each page of today's lesson, showing that you followed along, and to complete the practice page 2. Answer key for your practice page will be provided for you, and we are hoping that you will be submitting all of your work either through Canvas or through Google Classroom, depending on whose class you're in. So I hope this video has been helpful for you. If you have any questions, please feel free to contact your teacher for more clarification, and we hope to see